So I think I'm going to skip this warm-up and just focus on our key idea, which is exponential functions. Exponential functions are of the form like 2 to the x power, where your base is a number and your variable is up in your exponent. So they can grow really, really quickly because they're like doubling or tripling as you go from one y value to the next. So this one, if I was graphing it, I would just pick some x values to plug in, like any old graph, maybe -1, 0, and 1. And then if you take 2 to all of those powers, well, 2 to the negative first is going to flip it, make it 1/2. Anything to the 0 is 1, 2 to the first is just 2. If you plot those on your graph, we only did 3, so it might not give you the greatest idea of what your shape's going to be, especially on the first couple. Maybe I'll go over and do another one. 2 to the second would give me the 0.24. So if I was to do additional x values, my y's are going to get really close to my x-axis but not cross it. So these are going to have horizontal asymptotes along the x-axis. If you do like -2, you'll get 1/4, -3, you'll get 1/8. So it'll get really, really close to the x-axis but not cross it. My domain's going to be -infinity to infinity because it continues left and right. And since it does never cross below the x-axis, all my y values are greater than 0. So not including 0, it's a parentheses, up towards positive infinity for my range. You could have translations. So like on this one, I would just think of it as 1/2 to the x as your parent function. And then since that's like a separate +1 out to the side, it's going to get translated up 1. So I would just do like 1/2 to the -1, 0, and 1 first, which will give you 2, 1, and 1/2. And then do your translation, add 1 to all your y values to shift it up 1, which puts you at 3, 2, and 1.5. So this one's actually exponential decay because as your x values get larger, it's getting smaller instead of bigger. If I plot these, since it was translated up 1, your horizontal asymptote isn't going to be along the x-axis anymore. It's been moved up 1 as well to the line y = 1. So make sure you shift that asymptote up and then draw your line in so that it goes towards that horizontal asymptote. So same kind of curved shape going towards the asymptote that's shifted up 1. Your domain's still -infinity to infinity. It will be for all of your exponential functions. The range, since it is translated up 1, your y values are going to start a little bit bigger than 1 and go towards positive infinity. Why don't you guys snag some scratch paper, try this one, and then we'll come back and check in a minute. So I asked you to give this one a try. Hopefully you did. I'll give you a quick rundown of how it should have ended up. So I would do -2 to the x as your parent function, and then it should get translated left 2 since the +2 is like up in your exponent with your x values. Be a little careful with your order of operations, so make sure you take your 2 to the power and then multiply it by the -1 that you have outside. So you should end up with those points for your parent function. And then if we're moving things left 2, I'm just going to take and subtract 2 from all of my x values to get my final points. So plotting those on your graph should give you a graph that kind of is reflected because it has that negative out in front. So it's going down below the y-axis. It's not translated below the x-axis and y-axis actually. It's not actually translated up or down, so it still approaches the x-axis as your horizontal asymptote. Domain, always -infinity to infinity, but your range this time, 0 is like the largest y value that it's approaching. All the y values are actually less than 0, so your range will be -infinity to 0. Okay, switch topic. We're going to look at some exponential equations. Simplest one is something where your bases match. So if you look at this, to make both sides equal, you know that the x has to be 2 in that equation. When the bases aren't the same, your first step is going to be rewrite them as powers of the same number. So like 9 is a power of 3, and 27 is also a power of 3. So let's change 9 to 3 squared. It still equals 9. That's key. Has to be the same as what you started with. We just wrote it in a different way. Also, 27 is still equal to 3 to the third. I just wrote it as 3 to the third instead. So they both have a base of 3 now. If I use my exponent properties and multiply those exponents together, I could rewrite it as 3 to the 4x equals 3 to the 3x minus, I realized I just messed that up, 3x minus 3 power. And then since your bases match, to make sure that both sides of the equation are equal, we just have to ensure your exponents are equal. So set 4x equal to 3x minus 3, see what x value makes that happen, and it's negative 3. Same story here. You could, again, think about what you could use as your base to get both of those bases the same. If you did 3 to the negative second, since like 3 squared is 9, 3 to the negative second would be 1 over 9. Then you could run through, multiply your exponents. I'll get it right this time. Set those exponents equal to each other and solve it for x. Most difficult part is probably the first step. You don't necessarily have to use the same like power as I do. You could do something crazy like 9 to the 1/2 power and then 9 to the negative first, but use whatever's easiest for you. This has e's, which actually honestly makes it easier because that's 1 over e, so e to the negative first. That's 1 over e squared, e to the negative second. Basically, your base has to be e. Again, multiply your exponents together. Set your exponents equal because that'll make both sides of your equation equal. And then you should be good to go if you add 2x to both sides and divide by 3. X equals negative 2/3. Why don't you try this one and make sure that it turns out okay? Type your answer on the next slide.